Assalamualaikum warahmatullahi wabarakatuh. My name is Muhamad Nazreen bin Rahim. I'm 1BMMF student from FTKMP faculty. In this video, I want to talk about automotive additive manufacturing. Also, in this video, I want to tell you how 3D printing is done in automotive industry. Step 1. Correct the measurement of the part that you want to print. Step 2. Design the model with using AutoCAD software and others. Step 3. Slicing. After getting the model, then you need to slice up the file into different layers with slicing software and send the file to the printer. Step 4. The type of the printer. There are few of type of the printer nowadays, but we must choose the compatible with the project you want to do. Step 5. Operate the 3D printer. Send file to the printer and start printing it. After the 3D print is done, remove the model from the 3D printer and test it. Next, I will show you the clip how to perform it. Let's go.
A few years ago, someone had told me that this intake manifold is 3D printed. I don't know if I'd believe them. It really looks like a casted piece. The guys that made it were nice enough to let us film the whole process, and I'm going to share that with you guys now. Let's check it out. The place that did the printing for us is called Mimotechnik in Carson, California. Inside this office building is this crazy printer called an SLM 500. They actually have a couple of them. One set up for aluminum, like what we used, and another one set up for Inconel alloys, high temperature nickel that they use for exhaust manifold collectors, headers, and other automotive parts and aerospace stuff as well. We already had our intake manifold CAD designed, so all the computer-aided design was done, and we gave that solid model over to the Mimotechnik guys. They took our CAD model and then programmed the support and then the print strategy for the machine. The way the machine works is it uses really small powder aluminum. So the manifold is going to be made out of this powder. And the way it works is it lays down a 2/1000th of an inch layer of this aluminum powder. That's 0.002. Then it laser welds the first layer of powder to the aluminum plate. That's how they get the material to stick initially. Then the machine comes back and lays down another 2/1000th thick layer of material. So that's half the thickness of a human hair. Then the laser turns on again and welds it in all of the locations where the intake manifold is going to exist. And it does it layer by layer, so cross-section by cross-section. So it keeps putting down a layer of the powder, then laser welding it until you have an entire part. Just the plenum for the intake, the larger round piece for the intake manifold, was 6,991 layers, and the print time took 51 hours. Yeah, over 2 days of printing to get the one piece. Once the print is done, it's actually submersed in all of the powder. So then you have to get the part out of the powder. So you transfer the big box with the part and all of the powder in it over to the unpacking station. You don't want to breathe that powder because it's so small, it's not good for you. So typically they'll wear respirators. They do it in this unpacking station with gloves and everything and a vacuum until you have just the part left, and then they recycle the leftover powder for future parts. So after it prints each layer, the platform goes down that 2/1000th of an inch until the whole box is filled with your part and the powder. In the unpacking station, it goes the other way. The plate will come up and then start exposing the part, and you can see all the powder falling off of it. And then after a few hours of dusting the whole part off and vacuuming everything up, then you've got your part left, and it's safe to handle, but it's not ready to be used yet. Because it's actually welded with all of the support, that's what you see are those, like what looks like cascades of aluminum coming down. The parts actually have to be cut off of the plate because they're welded on right now. But once it's cut off, then it's actually relatively straightforward to clean it up and get it ready to be welded together. The support breaks off relatively easy with just some pliers and then goes and gets recycled. Because the intake manifold is so large and the envelope of the printer is only so big, we actually had to print it in 4 different pieces, and we're going to eventually weld them all together. But before we welded it together, we wanted to make sure all of the surfaces were totally smooth. That way they have a good seal on the engine for the intake manifold. So we brought it over to the shop and fly cut the aluminum so we had a nice smooth surface. Once we had it machined, we brought it back over to Mimo Technic, where we bolted it to an aluminum plate, and that aluminum plate allowed Chris to weld it without it warping. Once the whole intake manifold was welded together, we had a couple more features that had to be drilled, and because these are precision holes that need to have a specific surface finish for O-rings for the fuel injectors, we again did that on our mill at the shop. We actually have a special drill bit that has the profile of the fuel injectors that we're going to use all in one drill operation. So even though there's a couple of steps in it, this drill bit has all of those features built in, and it's much quicker. You can just drill 6 holes and the injectors are ready to install. Because it's such an awkward piece, it would have been hard and taken a lot of time to fixture it to be machined. So what we did is we 3D printed a drill guide. We put these steel inserts into the 3D printed part. That way when we drilled the holes before we tapped it, they would be straight. Because it's really hard sometimes to drill holes straight. And then we also have this tap guide. That way the bolt can bolt in straight. We then put our Injector Dynamics 2000cc injectors into the fuel rail and bolted it all together. The factory engine in this car only has direct injection, which is a really good system, but for the horsepower we plan to make, we needed to run 6 additional injectors, and that's one of the reasons why we built this intake manifold. And the reason we 3D printed it was because we needed it so quickly. The 3D printing was something definitely expensive, but well worth it because of the time savings. And there you have it. All done, ready to get bolted on the engine.